Welcome to Forces of Motion. This is Lesson 4, Part 1. There will be 2 videos to this lesson. At any time that I am going too fast, feel free to pause the video so that you may catch up, take notes, and finish each activity as we move forward. Today we're going to identify types of forces. You are going to need your Forces of Motion book. We're going to be working on the bell ringers. Bell ringer 1. Which of the following is described as a push or pull? Did you choose D? Please do not write just D in your book. You need to write out the word force so that when you study and you go back in your book, then you are going to know what we're talking about. Number 2, a stronger force will have what impact on an object? Did you choose C? It will move the object farther. Number 3, which of the following affects the motion of an object? Did you choose D? Please do not write all of these. What I prefer that you do is to write friction, gravity, and mass of the object. We must know what we're talking about when we go back to study. Bell ringer number 4. Which object is the most massive? There we go. Bowling ball. Number 5, which object would fall with a greater force? A bowling ball is correct. Oops, wrong thing. Here we go. Number 6, which has the biggest impact on an object's direction? The direction from where it is hit. I know that many of you play soccer on a team or just for fun at recess, and we know that when we kick the ball, it depends on where we kick the ball is the direction that it goes. Some of you may play pool, and when you go to hit the cue ball, some people may talk about English on the cue ball, and it depends on where you hit that ball is how it's going to roll, and you're wanting it to hit another ball in a certain way. So you've got to hit it in such a way that it sends it in the direction that you want. So that is where the biggest impact on an object's direction is the direction from where it is hit. Number 7, in which situation would an object remain still? This one you may not know, but you will learn it as we go through these lessons. When forces are balanced, an object remains still. Number 8, which is another name for air resistance. You may need to think back to our field trip to NASCAR Hall of Fame. Um, this air resistance is referred to this way a lot when we talk about racing. Did you say drag? It would be correct. Drag is the air resistance, uh, and it's the friction from air, is what it is. And so it's friction that's caused, and when they're racing, they don't want that friction because that friction is going to slow them down. It is rubbing against them, and any friction at all causes the cars to go slower. So even from racing, motor racing, to sometimes in the Winter Olympics, when you see these speed skaters, they will wear this funny shaped helmet that is almost like a teardrop shape. And so it's pointed in the back but round at the front. And it is to help reduce air resistance. Remember the cars at NASCAR Hall of Fame? Our older cars, they were more blocky, the windows were more straight on them. Um, and so over time, our cars have become more streamlined so the air just flows over the car and it doesn't have that air resistance. It doesn't have as much friction as it did, say, 50 years ago. Let's go on to page 10 in the book. So just go ahead and turn in your book to page 10 right here. And we will start right here at the top of the page. How do you think mass and weight differ? This says to discuss it with classmates and record your responses below, but we know that in this situation we can't. So pause the video, write down your thoughts on how you think mass and weight are different. Think back to our previous unit. We talked some about mass and weight then. So mass refers to the amount of matter contained within an object. It can vary in areas of differing, sorry, can it vary in areas of differing gravitational pull? So does the mass change based on how much gravity is pulling on the object? No. The amount of matter contained within an object remains constant regardless of the gravitational pull. So just because I may travel to the moon, it doesn't mean that because there's less gravity pulling on me, that suddenly there's going to be less matter in me. Does an object's mass depend on its weight? No. Weight may vary depending on gravitational pull, yet mass remains constant. So, for example, we may go to Charlotte, get on a plane, and fly to the equator. And when we're at the equator, we're going to have less gravitational pull than we would here. So the weight would be different, but the mass would remain the same. There would still yet be the same amount of matter in me, whether I am here or at the equator. And I can hear some of you now. But what if you pooped on the plane? Well, if you pooped on the plane, well, there'd be a little bit less matter in you. But for the most part, the mass of you, the matter within you, remains the same. Gosh, I miss you all. So use the space right down here at the bottom of page 10 to create a graphic organizer, a picture, demonstrating how mass may affect the motion of an object. How mass is going to affect the motion of an object. Hint, larger mass equals greater force needed to move the object. So think about the difference in kicking a beach ball compared to kicking a bowling ball. All right, so I'm going to move right on. So weight refers to the force of gravity exerted on an object. Can it vary in areas of differing gravitational pull? Weight refers to the force of gravity exerted on an object. Can it vary in areas of differing gravitational pull? Yes, it can. If the gravitational pull varies, weight will vary as well. That is the same thing as I was talking just a moment ago about if we went to the equator, the gravitational pull would be less, so we would weigh less. We wouldn't have less mass, we would just weigh less. Whereas if we went to Antarctica, then and weighed ourselves, we are going to end up weighing more because of a stronger gravitational pull. And yes, I can hear you now. You're going to have clothes on, lots and lots of clothes in Antarctica, but that's not the part of you I'm talking about. I'm talking about just your body. Moving on. Still yet on page 11. Does an object's weight depend on its mass? Yes. Weight is a measure of the gravitational force exerted on an object's total mass. So the weight is just a scale that we go by to determine how much something weighs. Just a measurement, a figure that we can relate to. So here we may go by weight for health reasons. But if we were to say, give the doctors our weight from the moon, well, that would be some totally different answer. And it would be about 1/10 of the weight that you have now. And it wouldn't help the doctors at all because we're talking about a totally different area. So gravitational force is just how much the gravity is pulling down on the amount of you that's there. So at the bottom of page 11, you're going to see this chart. And you can see I put a big X over it. So just make a big X over that because you're not going to have to do that. And then when you turn to page 12, you see on that chart, I also put a large X, and I would like for you to do the same. And then at the top of page 13, we begin again. Friction is a force that opposes motion. It goes against it and will slow an object down. There are 4 types of friction that affect objects' motion. So friction is going to slow it down, like we were talking about air resistance or drag a moment ago. That is going to slow down the race cars. That's going to slow down the speed skaters. It's like you putting your hand out the car window and you may cup your hand this way and feel a lot of drag come back. But if, I'm trying to get my hand in the video, but if you tilt your hand this way, the air flows over it and you don't have as much drag, so there's less resistance. I'm going to pause the video. This is the end of video 1. You will have video 2 to watch.